Hey everyone, ready for another deep dive?
Always ready.
Today we're tackling something that's become pretty crucial in our tech-driven world, secure software development.
Yeah, it's kind of crazy how much we depend on software for everything.
Right, from our phones to, well, even cars are basically computers on wheels these days.
It's true.
So to guide our deep dive, we're using secure and resilient software development, chapters 1 through 12. It's like our roadmap to understanding how to make the software we rely on, well, safer.
And not just safer, but more resilient, right?
Absolutely.
Yep.
Software that can handle, whatever gets thrown at it.
Exactly. It's not just about preventing hacks. It's about building systems that can adapt and keep running even when things go wrong, which, let's face it, they sometimes do.
All the time. And chapter 1 actually dives into some pretty eye-opening examples of what can happen when software fails.
Oh, yeah, those historical cases, they always get me. Remember that time a power grid went down because of a software vulnerability?
Yeah, I remember reading about that. Entire cities in the dark.
Crazy, right. And then there was that massive data breach at that financial institution, millions lost.
It's scary to think about the impact these vulnerabilities can have.
Definitely makes you realize how critical it is to build software that can actually withstand, attacks and failures.
And that's where those non-functional requirements come into play.
Non-functional requirements.
Yeah, like security and resilience. They're not always the most glamorous part of software development, but they're essential.
Right, because it doesn't matter how cool your app is if it crashes all the time.
It's like you wouldn't buy a car that looks amazing but breaks down every few miles, right?
No way. You need that reliability.
Exactly. And chapter 2 really dives into the core characteristics of secure software. What makes it tick.
What stood out to you there?
I think the idea of fault tolerance really grabbed my attention.
Fault tolerance, huh?
Yeah, the idea that a well-designed system can gracefully handle failures without everything collapsing.
Like a domino effect.
Exactly. Imagine a website crashing during a huge online sale.
Oh, that's a nightmare scenario for any company.
Total disaster. But with fault tolerance built in, the site could potentially stay up, even with some parts failing.
That's impressive. Preventing frustrated customers and lost revenue.
Right. So it's not just about, preventing those big crashes, but also handling those smaller hiccups smoothly.
I see. So fault tolerance is a key player in resilient software.
It is, along with things like availability, scalability, and maintainability.
Right. Making sure the software is accessible, can handle growth, and can be updated without breaking everything.
Exactly. And, chapter 3 emphasizes that security can't just be an afterthought. It needs to be baked into every single step of the development process.
From start to finish.
Totally. Which brings us to the concept of security in the SDLC, the software development lifecycle.
SDLC. Makes sense. So we're talking about weaving security into every phase, from the initial brainstorming to the final deployment.
Yeah. And activities like threat modeling and code review become super important checkpoints along the way.
So it's a constant process, not just a one-time fix-it kind of thing.
Right. And chapter 4 goes even deeper, introducing some of the golden rules of secure design.
Golden rules, huh?
Yeah. Principles like defense in depth and fail secure design. And what's really cool is how these concepts apply beyond software.
Oh, interesting.
Defense in depth is, having multiple layers of security. Imagine your house with locks, an alarm system, maybe even some motion sensor lights.
Okay, so layers upon layers of protection. Makes sense.
Right. And fail secure is kind of like having a backup generator that kicks in during a power outage, making sure essential functions still work, even when the main power is down.
So even if one system fails, there's a backup plan ready to go.
Right. And then there's the least privilege principle.
Least privilege.
Yeah, it's about making sure that users and even different parts of the software itself only have access to the information they absolutely need.
So limiting access to reduce potential damage.
Exactly. I actually read about a data breach where someone had way too much access and was able to see information they shouldn't have.
Yeah, that's a prime example of why least privilege is crucial.
Absolutely. And it's great that Chapter 4 also points to some helpful tools like OWASP, ESET-PI. It's good to know there are resources out there for developers.
Practical tools to put these principles into action. Love it.
Right. So we've got our secure design principles in place, but how do we proactively find those weaknesses, those vulnerabilities, before someone else does?
Good question.
Well, that's where Chapter 5's threat modeling comes in.
Threat modeling. Sounds intense.
It is, but in a good way.
Hmm.
I like to think of it like a detective's investigation, but for software.
Okay, I could see that.
Frameworks like Stride help us systematically examine a system, searching for potential vulnerabilities.
So we're basically playing the role of the attacker, trying to figure out how they might try to exploit the software.
Exactly. And then we figure out how to plug those holes before they become a problem.
It's like preemptive security planning.
Exactly.
Right.
We've designed our fortress, we've done our detective work, and now, well, we need to write the code that makes it all come together.
The actual building process.
And Chapter 6 is all about secure coding practices.
So now we're getting into the nitty-gritty details of writing secure code.
And I'm curious how these practices connect to the principles we've been discussing.
Well, think of it this way. We have our blueprint for a secure system, right? Secure coding practices are like making sure the actual construction follows those plans to a T.
Okay, that makes sense. So it's not just about the big ideas, it's about the careful execution of every line of code.
Exactly. It's like having a detailed recipe for your software, one that's hard to mess up or tamper with.
And if the recipe is flawed.
Disaster. Well, maybe not a full-blown disaster, but definitely some unwanted bugs and vulnerabilities.
Right. Which could lead to, well, all the problems we've been talking about.
Exactly. And our source material points out some common vulnerabilities like SQL injection and XSS. These are sneaky ways attackers can exploit flaws in the code to, gain unauthorized access.
Sneaking in through the back door.
That's a good way to put it.
So what are some of the ways developers can actually prevent these types of attacks?
Well, there are specific techniques for validating and sanitizing user input to prevent SQL injection, and ways to escape output to thwart those XSS attacks.
It's like putting security checks at every entrance and exit point of your software.
Making sure nothing malicious gets in or out.
Exactly. Now, I'm really curious about how secure software development is changing with all these new technologies popping up. Chapter 7 tackles that, right?
It does. It looks at embedded systems, cloud computing, mobile apps, all sorts of exciting areas.
Yeah. And I know our listeners are really keen to learn more about these areas. What are some of the unique challenges you see there?
Well, each area comes with its own set of hurdles. Let's take embedded systems, for example.
Okay, embedded systems.
Think about the software that controls, like, medical devices or critical infrastructure.
Oh, wow. Yeah.
These systems often have limited update capabilities, so you've got to build in long-term security strategies right from the start.
You can't exactly issue a software update for a pacemaker every time a new vulnerability pops up.
Exactly. And then you have cloud computing, which relies heavily on robust encryption and access controls.
Making sure that sensitive data is protected, both when it's moving around and when it's just stored somewhere.
Right. And then there's mobile apps, which are constantly collecting and transmitting data. Mobile app security focuses on things like data minimization, secure communication channels, and platform-specific security measures.
There's a lot to juggle.
It is. Staying ahead of the curve requires a good understanding of both the technology and the evolving threats out there.
So how do we make sure our software is up to the task?
Testing. Chapter 8 talks about all the different types of security testing.
Testing, right. Because we need to know if our defenses actually hold up.
Exactly. It's like putting your software through a rigorous inspection. Think of static testing, like analyzing the blueprints of a building for structural flaws.
Okay, I can see that.
And then dynamic testing is more like simulating an earthquake to see how the building holds up in action.
So testing in different environments and under different conditions.
Right. And then there's penetration testing.
Ooh, penetration testing? That sounds intense.
It is. It's like hiring a team of ethical hackers to try and break into your system and find weaknesses.
Like a real-world test in a controlled environment.
Exactly. Each type of testing provides a different perspective and helps uncover those hidden vulnerabilities.
Now, Chapter 9 throws in an interesting challenge. Securing commercial off-the-shelf software, or COTS.
COTS. The software you buy but don't have access to the source code.
Right, so how do you even approach security when you can't see the inner workings?
It can be tricky, but there are frameworks and initiatives out there, like the Common Criteria, that help evaluate and mitigate risks with these types of products.
So even though you can't see the code, you can still get a sense of how secure the software is.
Exactly. And organizations like Beat SFSTC work specifically on improving the security of CO2's software. So there are resources and solutions even in this tricky situation.
That's good to know. So we've covered secure design, coding practices, testing, even dealing with that COT situation. But how do we bring it all together into a comprehensive strategy?
That's where Chapter 10 steps in, introducing CLOSP, the Comprehensive Lightweight Application Security Process.
CLOASP, it's a mouthful.
It is, but it's all about integrating security into every stage of the software development lifecycle.
Sounds like a pretty thorough approach.
It is, but it's also modular. It's like a toolbox filled with security components. Organizations can choose the tools that best fit their needs.
So it's adaptable, customizable.
Exactly. And it stresses the importance of defining clear security metrics. Yes. It's not enough to just do security. You have to be able to measure how effective your efforts actually are.
To see if it's actually working.
Right. By tracking things like vulnerability discovery rates and remediation time, you can pinpoint areas for improvement and show the value of your security program.
It's like having data to back up your security decisions.
Data is key. And Chapter 11 takes this idea of measurement a step further with security maturity models like OpenSAM and BSIM.
Maturity models. I've heard those terms thrown around, but honestly, they've always intimidated me a bit.
I get it. They can seem complex, but think of them as benchmarks for your organization's security posture.
Okay, benchmarks. That helps.
They help you assess where you stand and where you need to go in terms of security.
So instead of just hoping our security is good enough, we can use these models to actually measure our progress against, industry best practices.
Exactly. It's like having a roadmap for your security journey.
Now, Chapter 12 takes a bit of a turn, focusing on the human side of things: education, certification, and community involvement.
Because security isn't just about technology, it's about people.
It's true. You can have the best tools in the world, but if the people using them aren't security conscious, it's all for nothing.
It's like having a state-of-the-art security system for your home, but leaving the doors unlocked.
Right. So how do these elements, education, certification, and community, contribute to a more secure software landscape?
Well, education and training are essential for building a security-minded culture within organizations.
Right. So everyone understands the importance of their role.
Exactly. And certifications like CSSLP help validate that expertise.
Showing that someone has the skills and knowledge to build secure software.
Exactly. And then there's the community aspect. The source material highlights initiatives like OWASP, the Open Web Application Security Project.
OWASP, I've heard of them. They're like a giant hub for security knowledge.
They are, and they foster collaboration and knowledge sharing through conferences, workshops, online forums, even developing open source security tools.
So it's a global community working together to make the internet a safer place.
That's the goal. And it really shows how powerful collective action can be.
It's amazing to see the impact they've had. But it feels like we've only just dipped our toes into the vast ocean of secure software development.
Right.
What other strategies are out there?
Well, that's a great question, and it's something we'll be exploring further in the next part of our deep dive. We'll be getting into the nitty-gritty details of secure coding practices, the techniques and tools that developers use to create truly resilient software.
Stay tuned, folks. The adventure continues. All right, welcome back, everyone. I hope you're ready to keep diving deeper into the world of secure software development.
I'm ready when you are.
Great. In the last part, we look at the big picture, those foundational concepts, the principles, the challenges, all those things. Now it's time to get a little bit more practical.
Yeah, time to start putting those ideas into action.
Exactly. And Chapter 10 of our guide, Secure and Resilient Software Development, introduces this concept called KSP, the Comprehensive Lightweight Application Security Process.
KLSP.
Okay. And what I find interesting about KLSP is that it's not a one-size-fits-all kind of approach.
Yeah, that rigidity can be a problem sometimes, right? Trying to force a square peg into a round hole.
Exactly. And KLSP seems to understand that it's more modular.
Modular. Huh?
Yeah, like a toolbox full of different security components. Organizations can pick and choose the tools that fit their specific needs.
So it's adaptable, customizable. I like that.
Me too. But wouldn't that make it hard to, ensure a consistent level of security across different projects?
Well, that's where the lightweight part of CLASP comes in. It focuses on the most critical security practices without adding, a ton of extra work.
Okay, so it streamlines things.
Exactly. And it really emphasizes the importance of defining those clear security metrics.
That's right. What gets measured gets managed.
That's it. You got to be able to track your progress, right? See if your efforts are actually paying off.
And justify those security investments.
Exactly. So by tracking things like vulnerability discovery rates and how quickly you can fix those issues.
Remediation time.
Right, remediation time. You can really see where you need to improve and, prove that security is worth investing in.
Makes sense. And Chapter 11 takes this idea of measurement even further, introducing those security maturity models like OpenSAM and BSIM.
Yeah, maturity models.
I have to admit, those always sounded a bit intimidating to me.
I get it, they can seem complex, but really they're just frameworks for assessing and improving your organization's security posture.
Posture.
Yeah, like how mature and robust are your security practices, really?
Okay. So instead of just guessing if our security is good enough, we can use these models to see where we actually stand.
Right. And then you can see how you compare to industry best practices, see where you need to grow.
It's like having a roadmap for your security journey.
Exactly. You know, it's interesting, this concept of maturity models, it goes beyond just security.
Really?
Yeah, I've seen similar models used in project management, software development. It's a powerful tool for continuous improvement.
So always room to grow. Now, Chapter 12 kind of shifts gears and focuses on, well, the human side of secure software development.
The people factor. Can't forget about that.
Right. Talks about education, certification, community involvement. And I'm curious, how do those things, contribute to a more secure software landscape?
Well, we can have all the fancy tools and processes in the world, but if the people building and using the software aren't thinking about security.
It's all for nothing.
Exactly.
Yeah.
So building that security conscious mindset, that's where education and training come in.
Making sure everyone understands the importance of their role in keeping things secure.
Right. And certifications like CSSLP, the Certified Secure Software Lifecycle Professional, can help validate those skills.
Show that someone knows their stuff when it comes to secure development.
Exactly. And then there's the community aspect. OWASP, the Open Web Application Security Project, is a great example of this.
OWASP. Yeah, they're a big name in the security world.
They are, and they're all about collaboration, knowledge sharing. They do conferences, workshops, have online forums, even develop open source security tools.
So it's a whole community, a global network of experts working together to improve security.
That's the idea. Sharing knowledge, learning from each other's experiences, working together to make things better.
Now, earlier we talked about some common vulnerabilities, like SQL injection and XSS. Any tips for developers on how to protect against these types of attacks?
Absolutely. For SQL injection, the key is to never, ever trust user input.
Don't trust anyone.
Well, at least not when it comes to data input.
Right.
Always validate and sanitize any data that comes from outside sources before you use it in your database queries.
It's like having a security guard at the entrance to your database, checking everyone's ID.
Exactly. And for XSS, you want to make sure you're properly escaping all output that gets displayed to users. That prevents attackers from sneaking in their own malicious scripts.
So you're basically neutralizing any potentially harmful code before it can do any damage.
That's it. It's all about thinking ahead, anticipating those potential attacks, and taking steps to prevent them.
So secure coding is all about vigilance, attention to detail, and really understanding the threats out there.
It is. But like we've been saying, those resources and tools we talked about earlier can really make things easier.
And creating that culture of security, making it everyone's responsibility, that's huge.
Totally. It can't just be the developer's job. Everyone needs to be on board, from the project managers to the executives.
Security is a team sport.
Exactly. Making sure everyone understands that security is not an afterthought. It's a core part of building great software.
So as we move into the final part of our deep dive, what's the big takeaway you want listeners to remember?
I think the biggest lesson is that secure software development is a journey, not a destination.
A journey, huh?
Yeah, it's a continuous process of learning, adapting, staying ahead of the curve as those threats keep evolving.
Because the world of tech is constantly changing.
It is. But it's a journey worth taking, right?
Absolutely. The software we create impacts so many lives. We have a responsibility to make sure it's as secure as possible.
I agree. And by embracing those secure coding practices, building that culture of security, and always being willing to learn and adapt, well, we can make a difference.
Well said. Ready for the final leg of our journey.
Let's do it.
Welcome back, Deep Divers. Are you ready to finally get into the code itself?
Absolutely. This is where the rubber meets the road, right?
It is. We've explored the concepts, the strategies, the tools, and now it's time to see how it all comes together in the actual code.
Chapter 6 of our source material, Secure and Resilient Software Development, really dives deep into this, offering practical guidance for developers.
So if we're thinking like developers now, what are some of those key takeaways from Chapter 6? What should every developer keep in mind when writing secure code?
Well, one thing that really stands out is the importance of following secure coding standards. They're like blueprints for secure coding, providing guidelines and best practices to help avoid common vulnerabilities.
It's like having building codes, but for software.
Exactly. You wouldn't want a building to collapse because someone cut corners on the construction, right?
Definitely not. So having those standards helps ensure that the software is built on a solid foundation.
Right. And there's some great resources out there like OWASP Secure Coding Practices Quick Reference Guide.
WASP, yeah, they're a great resource.
They are. And that guide offers practical advice on how to handle all sorts of specific security risks.
I remember you mentioned automated tools earlier in our deep dive. It seems like they play a big role in secure coding as well.
They do. They're becoming more and more sophisticated all the time. Think of them as like a co-pilot who's constantly checking your work and pointing out any potential issues.
Like a spell checker for security.
That's a great way to put it. Static analysis tools can scan your code for potential security flaws even before you compile it. And then there are dynamic analysis tools that test your software while it's running, simulating real-world attacks to see how well it holds up.
So it's like having a team of ethical hackers constantly testing your defenses.
Exactly. And beyond tools, you also have secure coding frameworks.
Frameworks.
Yeah, they provide pre-built components and libraries that are designed with security in mind.
So developers don't have to reinvent the wheel every time, which reduces the chance of introducing new vulnerabilities.
Exactly. And these frameworks are constantly being updated and improved by the security community.
It's great to see that collaboration, that everyone is working together to make software more secure.
It really is. Now, I know we talked about SQL injection and XSS earlier. Any specific tips for developers on how to prevent those types of attacks?
Those are some pretty common vulnerabilities, so I'm sure our listeners are wondering the same thing.
For SQL injection, the most important thing is to never trust user input. Always validate and sanitize any data that comes from external sources before using it in your database queries.
Okay, so it's all about making sure that only clean, safe data gets into your database.
Right. And for XSS, the best defense is to properly escape any output that's displayed to users. That prevents attackers from injecting their own malicious scripts.
So basically, you're neutralizing any potentially harmful code before it can do any damage.
Exactly. It's about anticipating those potential attack vectors and taking proactive steps to mitigate them.
Secure coding sounds like it requires a lot of attention to detail, a lot of vigilance.
It does, but the tools and resources we've talked about can really help. And as we've emphasized throughout our deep dive, it's also about creating that culture of security within the organization.
Right, making security everyone's responsibility.
Exactly. It's not just the developer's job. Everyone, from project managers to executives, needs to be on board and understand that security is a core part of building great software.
So as we wrap up our deep dive into secure software development, what's the key message you want our listeners to take away?
I think the most important thing to remember is that this is a journey, not a destination.
A journey.
Yes, a continuous process of learning, adapting, and evolving to stay ahead of the curve. The threat landscape is constantly changing, and we need to be prepared to change with it.
And it sounds like it's a journey worth taking.
It absolutely is. The software we create has such a profound impact on our lives, and we have a responsibility to make it as secure and resilient as possible.
Well said. It's been an incredible journey exploring this world of secure software development with you.
It's been my pleasure, and I hope our listeners feel inspired to keep learning and keep building secure software.
To all our deep divers out there, keep coding, keep learning, and stay secure. Thanks for joining us.